In a world we must defend. 11.9, the binomial theorem. Now, if you notice, we already did 11.9, but that was Pascal's triangle. This 11.9 is the binomial theorem, which is another way to expand binomials without having to use Pascal's triangle. Let's see what this is all about. All right, factorial. As you can see, there's a 5 and then there's an exclamation mark next to the 5. That actually means something. In mathematics, the exclamation mark is a factorial symbol. So the way you say this problem is 5 factorial. And what the exclamation mark does is it does this. It just means you take 5 and then times 4, then times 3, times 2, and then of course if you just times 1, it's the same thing. But you don't go past 1, you don't go to 0, because obviously if you go times 0, everything goes away. And so that's how you do factorial. 5 factorial is the same thing as 120. You can also do it on a calculator because sometimes the number I give you might be too big, like 15 factorial. And then it would be a little bit of a hassle to do 15 times 14 times 13 times 12 times 11 all the way to 1. That's a lot. So your calculator will do it for you. So the first thing you do, punch in the 5. And then you should see a button that says math. It's right here. Once you punch math, at the very top, you will see some choices. You want to go to PROB, probability. If you scroll to the right to get to probability, the fourth option down has an exclamation mark. You can either scroll down to number 4 or you can actually punch in 4. And then when you do that, the exclamation mark will appear next to your 5, and if you push enter, it'll give you the same answer, 120. All right, so it's kind of useful. Throw it in the calculator. Throw in 0 factorial into your calculator to see what that is. 0 factorial is always going to be 1. All right. All right, here is the binomial theorem. We use it to expand binomials, the a plus b to the n power. So we already did this with Pascal's triangle, with that triangle, and you find the coefficients. But this is another way to do it without having a triangle, so you don't have to fill out everything in the triangle to find the coefficients. We have this complicated formula. It looks complicated, but it's actually very easy to use. The n is just the degree of the leading coefficient. It's this n right here. It's whatever degree we're trying to deal with. And then, of course, our factorial symbol. The k is just 0, 1, 2, 3, 4, 5, 6. So however many times we can go. And basically, all right, so let's see how we can use this formula. I wrote up in the little corner. Let's go ahead and expand x plus y to the 8th power. Now, we learned from Pascal's triangle that those are the x and the y's. The x, we always start with x to the 8th, and then it becomes x to the 7th, x to the 6th, x to the 5, 4, 3, 2, 1, and then there's no x. And then it starts with no y, and then y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, all the way y to the 8th. All right, so we did that for Pascal's triangle, which is nice because that pattern is really nice. But now let's look for the coefficients. Okay, and so that's what this part is for. All right, it is n factorial over k factorial times n minus k factorial. So basically, it is, we know that the first term is going to be 1 and the last term is going to be 1. Don't forget about that. But then this term, here's how the binomial formula works. You take the exponent, the 8, which is this one, and you put a factorial next to it. And then on the bottom, it's these exponents, the 7, and then I know the y doesn't have an exponent, but it's actually a 1. All right, so that's where the 7 factorial, 1 factorial comes from. That's the bottom part of the formula. Okay, next one. Let me clean it up a little bit. It's 8 factorial over 6 factorial 2 factorial. The 8 comes from here, and then the 6 and the 2 comes from here and here. All right, let's think about what the next coefficient is going to be. 8 factorial. That bell was for 6 period. 8 factorial over 5 factorial 3 factorial. Next one is 8 factorial over 4 factorial 4 factorial. And then so on, and then so on, and then so on. And even if you wanted to try to figure out how they got this 1, you can do that too. It's 8 factorial over 0 factorial because there's no x term, and then 8 factorial again. All right, let's evaluate all of those factorials. Let's do one at a time. 8 factorial over 7 factorial 1 factorial. If you write it all out, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times 1, and then an extra 1 for that 1 factorial. And if you notice, everything cancels out. Most of everything cancels out. And that's kind of fun with using factorials, is usually a lot of stuff cancels out. And we're left with just 8. All of that work just to get an 8. The next one, you don't always have to expand it all out. There are little shortcuts. Like this one is 8 times 7 times 6. But instead of writing 6, 5, 4, 3, 2, 1, I'm just going to write 6 factorial. And the reason why I do 6 factorial is if you look at the bottom, it also has a 6 factorial. And so those cancel out. And then you just have a 2 factorial, which a 2 factorial is the same thing as just 2 times 1, which is just 2. And then from there, you can do a little bit of math. You can do 8 reduced with the 2 to get 4 and 1. And then 4 times 7 is just 28. All right. And then you do that for all of those factorials. You should get something like this. And this is the answer. We have 1x to the 8th power plus 8 x to the 7th y, and then all the way down to the end. All right. And even this last one right here, see the 8 factorial and the 8 factorial cancel out. And then 0 factorial we know is 1, and so that's why the coefficient was 1. All right. So that's how you use the binomial formula to expand these binomials. All right, here's another one, m minus n to the 4th. This one is a little bit tricky because it's a minus sign, but we still do it the same way. We start off with m to the 4th, always m to the 4th, and then m to the 3rd, and then m to the 2nd power, and then m to the 1st power, and then no m at all. Okay, then we do the n's. We start off with no n, and actually it's not just n, we're going to use this negative as part of the n. So no negative n, and then we have 1 negative n, and then negative n squared, and then negative n to the 3rd and negative n to the 4th. So yeah, that negative sticks with the n. Now, to come up with the coefficients, remember it is the original exponent over this exponent and this exponent. And then we do that all across. Okay. Let's go ahead and clean that up just a little bit. Now let's simplify. The 4 factorial over 3 factorial, 1 factorial, they cancel out, but there's still a 4 there. The 4 doesn't cancel. And so that's where I got this 4. You can also punch all of this into your calculator as well. But the problem is I tried it the other day when you do 4 factorial. On the bottom, you need to open up a set of parentheses. So you'd have to do 2 factorial in parentheses so that it knows that everything is on the bottom. All right, so yes, use a calculator to get all the coefficients, 4, 6, 4. And then here's the one part that now the negative does come into play. You have negative n to the first power. That actually turns this sign negative. But the next one, you have negative n to the second power. What happens when you have negative n, but you square it? It turns into positive, and so this stays positive. Negative n to the third power, that actually changes to negative. And then negative n to the fourth power changes it to positive. So here's our final answer. Let me erase some of that work so you can see the answer. M to the fourth minus 4m third n plus 6m squared n squared minus 4mn to the third power plus n to the fourth power. All right, so that's a lot. I have another example, but this time instead of 2 letters like m and n or a and b, what if I have an x and a 5? We do it the same way. Again, start off with x to the 7th power, and then x to the 6th, and x to the 5th, x to the 4th, all the way down until you have no more x's. And then you go 5. 5 to the 0 power, which is nothing. 5 to the first power, 5 to the second power, 5 to the third power, 5 to the fourth power. So you're basically, usually that would be a y, but now we've replaced it with a number, which is how you do the problem. Now let's go ahead and fill in the coefficients, the numbers that go in front of each one. It's 7 factorial because it's the leading degree for the coefficient. And then it's 6 factorial, 1 factorial. The 5 has a little 1 next to it. Go ahead and do that for all of them. Evaluate each one of them. Again, you can throw this into your calculator. It does give you a 7. All of this gives you a 21. But then there's more to simplify now, because now we have a 7 times a 5. That can go together to make 35. You have a 5 squared, which is 25, and that goes with the 21. Multiply those together. You have 5 to the third power, multiply it with the 35, and so on and so forth. And there's our final answer when we expand it. All right, it's kind of cool. Instead of superfoiling x plus 5, x plus 5, x plus 5, x plus 5, now we have this neat little shortcut way to do the problem. All right, this one is a tricky one because it has both the numbers in it and letters. So you have a 3a and you have a negative 2b. So you want to treat this as one thing and then this as another thing, like your x and your y. Here it is. The 3a started off with 3a to the 5th power. That's for that. And then 3a to the 4th, 3a to the 3rd, 3a squared, and so on. And then the negative 2b. There's no negative 2b here. Then you have negative 2b, negative 2b squared, negative 2b to the third. So same pattern. Now let's go ahead and fill in the blanks that we have saved up for them. It is 5 factorial, again, 5 factorial over 4 factorial, 1 factorial, and so on and so forth. Same as the last few examples. We can simplify this. Again, you can punch this into your calculator, or you can kind of do it in your head right now. The 4 factorials will cancel out, so it's just be 5. This one was for this one. And then you have a 5. Keep the parentheses because that's important when you do them. Because the next step is to do 3 to the 4th power. That's important. You do exponents first. 3 to the 4th power. And then you times that by 5. And then you times that by negative 2. All right? So that's important. Again, the next one. You do 3 to the 3rd power first, and then you multiply it times the 10, and then you multiply it times a positive 2. Now, why did I say positive 2? Because the squared will get rid of that negative. All right, and you do that for the rest of the line, and you should get this answer. Try it yourself and see if you get those actual numbers, because that's important. All right. All right, so this one is the next part of the homework. They don't ask you to expand the whole thing, a plus b to the 11th power. That'll take up the entire page. So what they want is they just want the 8th term. So instead of listing them out, dot, 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 they want, what's the 8th term? 4, 5, 6, 7, 8th term. So what is going to be here? All right, and it's actually very easy to do. The 8th term will always have 1 less power for that b term. So it'll always be whatever the b is, and then if they're asking for the 8th term, it's always going to be to the 7th power. So 1 less degree than what they ask for. There it is. Well, from that little piece of information, we can actually find out everything else, which is kind of cool. What do you think the a term, what its exponent is going to be? The 4th. Why is it the 4th? Because they have to always add up to the original 11th power. And then from there, you can come up with the coefficients. The 11 factorial over 4 factorial, 7 factorial. Punch it into the calculator. There you have it. That's the 8th term. How cool is that? All right, same thing, but this one's a little bit more complicated. I want the 4th term. And so when I want the 4th term, that means I want this part 1 less. So 3y to the 3rd power. That means the negative 2x, what power is it going to be? Also to the 3rd, because they have to add up to this original 6. From there, go ahead and put in the coefficient in the front, 6 factorial over 3 factorial, 3 factorial, and then simplify. This goes into the calculator. Don't forget about the negative 2 to the 3rd power. Don't forget about the 3 to the 3rd power. All of that counts. And then you should get negative 4,320 x to the 3rd, y to the 3rd. All right, one last example. I know this chapter is kind of long. I mean, this section is kind of long, but we'll get through it. This is the last one. All right. They give you x to the 3rd minus y squared raised to the 13th power. I want the term that has x to the 18th in it. Well, how do we get x to the 18th? We started with x to the 3rd, so to get x to the 18th, we actually want x to the 3rd to the 6th power, because 3 times 6 is the 18, if you remember your properties, power of a exponent property when we did those. All right, so if this is the x to the 18th, let's go ahead and figure out what the y, the negative y squared, is going to look like. Let me erase that. All right, it's going to be negative y squared to the 7th, because again, this and this have to add up to 13. From there, we get the coefficient, 13 factorial over 6 factorial, 7 factorial. Simplify with all of those, and we get negative 1,716 x to the 18th, y to the 14th. All right, I know, long lesson. Go ahead, try the homework.